In this video, I'm going to explain how you can avoid a very costly mistake that most AI beginners make when they try to become an AI expert or AI engineer. And to illustrate this, I'm going to be showing this example in N8N, which is a no-code workflow automation tool. And this is a place where a lot of beginners are starting out when they create their first AI agents. And the thing is, a lot of beginners have seen a lot of videos that really promise that these agents can do a lot. They can browse the web for you, they can automate any process, and they can really revolutionize whatever you're working on. And to some degree, it's true, these AI agents are very powerful, but what these videos don't mention is the cost aspect of a lot of these solutions, because actually letting your AI agents do whatever they please is going to be a very expensive operation in actual production environments. Now, that's a lot of theoretical talk, so I'm just going to show you this in practice. This is a very simple N8N workflow. A chat message is passed onto an AI agent, and this agent is using the Open Router chat model to call Claude 3.7 Sonnet. I've loaded up this Open Router with a couple of credits so we can see in real time how expensive this agent actually is. Next to this, the model has access to an MCP tool that I've hosted locally just for the purpose of testing. And this tool is actually Playwright. And Playwright is a tool that you can use to automate browsers. And you'll see how that works in just a little bit. So to test this very simple agent example, I'm just going to paste the following prompt. Go to the front page of a known box office site, find the top 5 movies of all time, and give me back a list sorted by highest box office result. So instead of the language model just coming up with the answer based on its own knowledge, it actually has to retrieve it from the internet. So I'm going to go and enter that, and let's see how this is going to be handled. So the chat model is calling that MCP client right now. You can see Chrome is opening completely autonomously. I've got my hands in the air. And now it's going to automatically go to the top lifetime grosses website. Now, once it's read that website, it actually passes that result back to the language model, and the language model can now process that entire HTML to figure out the answer to my question. So now you see that we get the top 5 movies of all time by box office, and we start with Avatar, and then Avengers, Avatar, The Way of Water, Titanic, and Star Wars. Let's actually double check this and verify if this is even true. So I've got the actual web page here, and I can go to all time worldwide, and then let's see if that actually aligns. So we have Avatar, Avengers, Avatar, The Way of Water, Titanic, Star Wars. Let's double check that again. And indeed, that is correct. We even get the dollar amounts, which do seem to be aligned properly, because I just pasted this number, and you can see indeed that is 100% correct. So the answer it gave is super great, and it did exactly what we expected it to do, completely autonomously. So what's the problem, you might ask? Well, let's actually have a look at how expensive this operation was. So this is the billing page for Open Router, and here you can see 4 rows that indicate all the request responses that we just did to perform that agentic workflow. And if you add this all up, you will have over $45 that were spent on this very simple query response pair. And I didn't even ask that complex of a question, neither did I have some of these complex workflows where AI agents can call other agents autonomously, which is something that a lot of other videos try to promote you to do. The problem here is just that costs get completely out of hand when you use the MCP tools like Playwright in the wrong way. Let me confirm and explain further why it was so expensive to run the large language model this way. Well, if we go to the N8N portal, we can actually have a better idea of what requests took so many tokens to run. So we start out with the very first request to the chat model, which is only 2,700 tokens, because we actually have a prompt that's 2,600 tokens and a little bit of completion, which is the output of the model. And of course, most of that input is just coming from my regular system message, as well as the human input that I gave, together with some metadata that lets the model know how to call the MCP tools that it has access to. So next, it actually calls the MCP client. It calls that Playwright server with this URL together with the tool to navigate to that with the browser. That makes a lot of sense. But this is where things start to get a bit trickier. Now we have a request that has over 11,000 tokens for the prompt. And the reason why the prompt is so large is because now it includes the result from that tool call. So if we scroll down here, you can eventually see that this tool call result has this text ran code navigate to box office mojo, and then it has the entire HTML of that page included in the results. And this is necessary because you need the language model to parse the page to understand if it needs to browse to another page or if it can answer the user's query with the current page that it has in its memory. Now, the model actually decides that this is not the case, because if we go to the next call, you see that MCP client is being called again. So MCP client is called again, this time with the request to click on the element with the text all time worldwide. So this is actually because if we go back to the homepage of Box Office Mojo, we have this button all time worldwide that indeed you need to click on to go to the page that actually has the answer to our question. So fair play, it asks the MCP server to return another page. So the MCP server comes back, and now we have a chat model request which has over 70,000 tokens. This is very, very expensive. And this is expensive because, of course, again, the new HTML page is being returned. So if I just scroll down to this point, you see that this tool call is ran code once more. And now you can indeed see that this is the page for the all-time movie records. But actually, if we go up, you will see that above that tool call, we still have that initial HTML for that very first web page that we actually requested. And this is important because sometimes you need to know the context of multiple web pages to answer a user's question. But you can see just how easily this gets out of hand. We only went to 2 pages, and we already have more than 70,000 tokens that we're requesting every single time. So if you had a complex AI agent workflow, then this could go completely crazy, and you might even just hit the token limit of the model that you're using. Next, when the model realizes that it can answer the question based on the web pages that it has access to, it calls the MCP client one more time, in this case to close the browser. And indeed, the browser did close, so that works well. And then one more time, it is going to call the chat model with, again, all of that URL context, because now it will actually try to answer the user's question. And this is the final request response pair that actually this answer came from that you see here on the left with those top 5 movies. So that's the whole request chain from beginning all the way to end. But you can just see it's incredibly expensive. And this is not a realistic cost for any production environment. Can you imagine if you had an AI application where 50 users were using the app simultaneously, and you would become bankrupt in no time. Now, sure, if you had like a homegrown automation that you just use as a hobby for a couple of different projects, this could be fine. Maybe you have also a different use case that actually justifies spending $50 on a single response from the model. But for most use cases, this is absolutely silly. I can tell you right now that most YouTubers promoting this kind of way of building AI solutions probably have never productionalized any AI system. And if they have, there's a good chance that they are not actually making a good return on investment, because these kinds of AI implementations are totally not cost effective. So what can you do about this to become a real expert AI engineer and implement a real solution that's optimized for cost? Well, this is where my AI Engineer Toolset comes in, and I'm actually discussing this toolset in detail in a different video of mine, but I want to quickly give a couple of examples that you can find in this toolset for how you could actually make sure that your AI solution is cost optimized. Well, in this case, what I would really recommend you to do is to learn how you can use Python to create your own backend for these AI applications. This is a clear example of where it's very easy to build a proof of concept in N8N, but where the actual proper production environment will not work in N8N because you lack the tools to customize these scrapers to your liking to make sure that you don't use so many tokens. If you learned Python, you could, for example, create your own scraper that only takes the limited information that you need to actually answer the question. But even if you were limited to just N8N, well, then there are other ways that you could actually improve the cost effectiveness of your solution. I've been using OpenRouter for this solution, but when it comes to invoking MCP models that can use a lot of context, well, this is where having a local AI model could be very beneficial, because then you're not paying on a token per token basis, You are occupying a local GPU because it needs to calculate the answers, but that's probably not as bad as actually having to pay a provider a huge amount of money every time a single user asks a simple question. So these are just two examples of technologies that you can find in my toolset that you can use to actually avoid this costly beginner's mistake. If you want to learn more about it, I will reference the YouTube video that has the toolset in full somewhere in this video right now. And if you want to become a real AI engineer, you can also consider joining the community that's in the link in the description below. I hope to see you in either place. See you there.